Hello everyone, welcome back. In this lecture, we shall solve a problem on heat transfer analysis over a flat plate for laminar flow condition. We shall solve using theoretical methods and compare the answer with CFD analysis results. The problem definition is given here. Water flows at 60 degrees Celsius over the upper surface of a 0.4 meter long flat plate whose temperature is 20 degrees Celsius at a velocity of 0.1 meter per second. The figure is given here. The length is 0.4 meter and water is flowing at 60 degrees Celsius and velocity of 0.1 meter per second. And the surface temperature of the flat plate is 20 degrees Celsius. Now we have to determine the rate of heat transfer per unit width of the entire plate. Okay, first let us solve using theoretical methods. Let us start. The properties of water at 60 degrees Celsius are given here. The thermal conductivity K is equal to 0.654 watt per meter per Kelvin. The density is 983 kg per meter cube at this temperature. The specific heat at constant pressure is 4182 joule per kg per Kelvin. The dynamic viscosity and kinematic viscosity are given here. So in this problem, we have to find out the net heat transfer rate from the hot water to the flat plate. Okay. To find out the net heat transfer rate, we have to calculate the conductive heat transfer coefficient, and to calculate that, we have to find out Nusselt number. Nusselt number can be found out using empirical correlation, which is function of Reynolds number and Prandtl number. Okay, first let us calculate Reynolds number. Reynolds number is given by rho v L by mu. We can substitute the values here. Reynolds number is equal to 8.42 into 10 power 4. This is less than the critical Reynolds number, which is 5 into 10 power 5. Therefore, the flow is laminar. Okay, now we have calculated Reynolds number over the flat plate. Next, we have to find out the Prandtl number. Prandtl number is given by mu Cp by K. When we substitute the values, we will get Prandtl number as 2.99. Okay. Next, using Reynolds number and Prandtl number, let us calculate the Nusselt number. Nusselt number is given by 0.332 into Reynolds number power 1 by 2 into Prandtl number power 1 by 3. Note that this is the local Nusselt number at a distance x. If you want to find out the average Nusselt number over the entire length L, then it is given as Nusselt number is equal to 0.664 into Reynolds number power 1 by 2 for the whole length L multiplied by Prandtl number power 1 by 3. Okay. Now we shall substitute the value of Reynolds number and Prandtl number in this expression. So we will get the average Nusselt number over the entire flat plate as 277. Okay. Now you have got Nusselt number from which you can calculate the conductive heat transfer coefficient H. Nusselt number is given by HL by K, that is conductive heat transfer rate divided by conductive heat transfer rate in the fluid. Okay. Now we shall substitute the values. The average Nusselt number is 277. We know the thermal conductivity and the length is 0.4. Let us substitute. Therefore, H will be equal to K into average Nusselt number divided by length. Substituting the values, we will get H is equal to 453.6 watt per meter square per degree Celsius. Okay. Now we can calculate the net heat transfer rate from the fluid to flat plate, which is given by H into A into T infinity minus Ts. We have got the H value. We shall substitute all the other values. H is equal to 453. Area is nothing but length into width. Here we have to calculate for per unit width. Therefore, it is 0.4 into 1. And the flow temperature is 60 degrees Celsius. Surface temperature is 20 degrees Celsius. Substituting this, we will get the net heat transfer rate as 7258 watt. Okay. This is from the theoretical calculation. Now we shall solve the same problem in Ansys CFX. We shall create the model, generate the mesh, apply the boundary condition and solve the case to find out the net heat transfer rate. Okay.